Hey, what's up, people? Meet again in a new week. So today I'm going to focus on finding the complex number that satisfies this equation. So basically it's a 2009-2010 question. Okay, so why did I select this question is because some students might be facing difficulties in solving the equation. Okay, so let us go and do this. So the good thing, right, if you look at the question is they told us what is z. Z is a complex number in the form of a plus bi. If they never mention, z equals to a plus bi, you should understand if anything is mentioned as complex number, it is of the form a plus bi. So let us go and substitute that. Okay, we know z is a plus bi. So I'm going to go and substitute into my equation. So a plus bi square equal to 8, 6. So now, please be very careful with this. Okay, so if you got square like this, okay, best to write it twice and expand it. So a plus bi, 6, 8. So this one you expand a square plus abi plus abi. This is the one that student normally make careless mistake. Bi times bi is going to be b square I square. Hope you are clear up until that. Now I can go and simplify. So a square, please take note, this is negative 1. That's going to be minus b square plus 2abi equal to 8. So I've simplified. Now both are complex numbers. So what I'm going to do now is I'm going to go and compare the real part and the imaginary part. So my real part, I'm going to get a square minus b square equal to 8. And my imaginary part is going to be 2ab equals to 6. I'm very sure most of you got until there. But I don't know, for some reason, some of you always have problems solving equation. How to solve the equation? Let's go and see. Hey guys, so I've rewritten it. Okay, I got rid of the unnecessary working. Just want to focus on solving this equation, meaning to say I want to go and get my value of a and b. So how do we do that? Okay, so if you see any equation, right, like this is quadratic. So you see you must either have in a or b. That means only one variable. So look at here. I can simplify. So that's going to be ab equal to 3. So doesn't matter, either a or b doesn't matter. So b is equal to 3 over a. Take the substitute here. So a square minus 3 over a square equals to 8. By law of indices, this is going to be 9 over a square equal to 8. Doesn't look good. Okay, please be very careful. If you want to get rid of this guy, you must multiply everything by a square. This is going to be a power 4 minus 9 equal to a square. I'm going to turn this around into this, okay, because you know always equation, it should equal to 0. So now this is something which is like you have not done before, okay, a power 4. The most you have done is quadratic. So quadratic means, okay, we try to make sure, okay, we get into a similar scenario, which is a quadratic. So what I'm going to do is I'm going to force this to be a quadratic. How do I force that? I go and let. So I go and let my y to be a square. Why? Because here normally is power 1. So I let it to be y. So if a square is y, then a power 4. How do I get that? I square both sides. So this is a power 4. This is going to be y square. Hope we are clear up until there. So I take it from there. This guy is now going to become y power 2 minus 8y minus 9 equal to 0. Quickly press your calculator, your EQ and things. And this is going to be y equal to, if I'm not mistaken, you're going to get 1 and also negative 9. Okay, hope I get that correctly. Okay, let me just quickly go and check. Y minus 1, is it? Minus plus. Okay, so it should be minus and then plus. Okay, factorization, y square plus minus, yes. So this should be positive 9, this should be minus 1. Okay, this is from my factorization. Okay, so we are not done yet, because what we are obtained is value of y. What I want is my value for a and b. So meaning to say my complex number just now I gave as a plus bi. So I want value of a and b. So here I recall what is my y. So my y is a square. So a square is equal to 9. And also a square is equal to negative 1. So if you see here, this guy, a square equal to 9, I don't want the square, so I square root. When I square root, remember you're going to get plus minus 3. Okay, so you're going to get two values for your a. And this guy, if you see, okay, there's not going to be solution. Why? Because when you go and see, when you square a number, remember this is a real number. So when you square a real number, you can never get negative. So this one, I'm going to say no solution. So I got two value of a. So for these two value of a, I can go and find my value of b using this guy. So you need to write when a equal to 3, your b is going to be 1. When a is equal to negative 3, your b is going to equal to negative 1. And remember, your final step, if they ask you for complex number, you need to go and show z is equal to 3 plus I, comma, and also z equal to negative 3 minus I. This is the one that will give you your final mark. We are done with part A, which is finding the complex number that satisfies the equation. We still got part B, which is expressing in polar form. Let's check out part B in the next video. Hey guys, so here is my part B. Okay, so part B is we have already obtained two complex numbers from part A. So my first complex number is this guy. So every time you want to go and express in polar form, remember polar form is in the form of r cos theta plus I sin theta. So these r and this theta, if you followed my previous videos, you know r is referring to modulus and theta is referring to argument. So I've already mentioned to you also, if you want to go and work out your argument, okay, please go and draw your argument diagram. So here, this is a very simple scenario whereby you are going to be in your first quadrant. So 3 is the real part, 1 is the imaginary part. So this is going to be my argument. And my alpha is also going to sit inside the triangle. So if you see here, theta is equal to alpha. So I easily calculate my alpha. My alpha is just going to be tan inverse of b over a. Please be very careful because this is the one that students always tend to make careless mistake. So your b here is the number in front of I, which is going to be 1. So my a is going to be the real part. So sub that in. Okay, let me grab my calculator. So you take tan inverse of 1 over 3. So that's going to give you 0.322. 2 decimal place is sufficient. And then you want to find your argument. So your argument is going to be just using formula a square plus b square. So that is going to be 3 square plus 1 square, going to be 10. So here you see, you don't get the exact value when you go and take the square root. So you just leave it in this form. Don't go and put in decimal. So this guy is just going to be, okay, final answer. I can go and put here, r is 10. Cos theta is going to be 0.322 plus I sin 0.322. We are done with the first complex number. We are not done with question B yet because I've got another one. Okay, so here we go, the second complex number that we need to go and express in polar form. So here I go and put this on Argand diagram. So on my Argand diagram, my real part is negative 3. My imaginary part is going to be negative 1. So I'm going to be here. So this is going to be my complex number line. So as already mentioned in my previous videos, I already told you we cannot go like this because it's going to be more than pi. So this is where my theta going to be. The angle between positive x-axis and complex number line. My alpha is going to be the angle inside triangle with the x-axis. So I can come up with the relationship theta plus with alpha is going to equal to pi. That is the size. I want theta only, so it is going to be pi minus alpha. But then I know I'm going in a clockwise direction, so I go and put a negative. So next I need to go and work out my alpha. My alpha is going to be tan inverse of b over a. So my b is going to be, please be very careful, is negative 1 over a negative 3. So we're going to get a similar value because I remember seeing 1 over 3 just now. So yeah, it's going to be 0.322. So now you go and put it here, okay, and that is going to be negative 2.820. That's pretty straightforward, isn't it? And if you see the number, okay, for your modulus, it's going to be similar with just now. Okay, your a is going to be negative 3. So negative 3 square plus with negative 1 square, that's going to be. So we are done with our calculation for our argument and also our modulus. I'm going to sub that in there. So that's going to be sert 10 cos negative 2.82 plus I sine negative 2.82. Okay, maybe sometime if you see your scheme, right, okay, you might realize that the negative is not there for your cos because cos is an even function. Okay, for example, if you go and check cos of 60 or cos of negative 60 is the same value. So the negative, okay, can disappear. And also for the sine, you can pull up the negative. Okay, so maybe your answer scheme might be something like that. Hope you enjoyed the video. I'll catch you in the next video. Ciao, guys.